Okay, guys, today what we're going to be talking about, all right, is a certain rule called the change of base rule. So there is, I don't know if you can see it. What we're going to do is we're going to use this screen right here. So I'm going to write it a little bit bigger. It says log, and it has a base b of a equals log, and it looks right here like they have an x right here of base a. So not a base a, of a over log, and I'll change it to an x so you can see it's base x of b. Now basically what this is saying is you can have any base here that can't be, it has to be positive, it can't be equal to 1, but you could have any base there and it works. Now, does everybody remember what the common log base is? If I say just log, what base goes right there even though you can't see it? It's a base 10. So we don't write it as log base 10, we write it as a common log. So technically what I'd like you to do is put log A over log B. Because you can use the common log every single time. So you could choose a different base, but you don't have to. You can just use base 10. So these mean the exact same. What does that x represent? Any base that's bigger than a 1, right? And any integer bigger than a 1, it's just, this represents base 10. Okay? So if we're using this rule, let me show you guys how you would use it. All right? So right here, if we wanted to evaluate log base 2 of 50, I could write it as log of 50 over log of 2. And that would you'd be able to evaluate that on most calculators. Okay? So if we do that on our calculator, and we just write what? Put alpha, y equals, enter. And I'm just going to put log of 50 and log of 2. You get to evaluate it, and that's the decimal. You're like, well, what does that decimal mean? So remember, what did we start out with? We started out with log base 2 of 50. Now, what are we actually solving for? I'll explain. 2 to the power of what number would get me a 50? My answer would be that right there. Watch. 2 to the power of this ridiculous decimal is 50. Now, why is it 50.00000? Why? Because it's a calculator and we're doing what? This is an approximate value. So when you guys are doing these, I want to make sure you understand what you're actually solving for. What does this piece right here actually solve for? It's solved for the exponential problem. 2 to the power of x equals 50. It solves for x. That's what logarithms do. It helps you solve for x when x is in the exponential realm. All right? So what we're going to do right here is we're going to go to the Khan Academy, and we're going to practice evaluating it. Okay? So you guys see where it says evaluate this logarithm? So what we're going to do, it says 3 times log base 9 of 1/12. Well, here's what I'd like us to do. See that power? Can you guys move that power up? Actually, you know what? We're not going to move it. We're not going to move it. Not going to do it. Not going to do it. Let's just use the change of base rule. All right? So we have what? 3 log 9 of 1/12. So what's sitting out there already? A 3. Let's use the change of base rule. And what are we going to put in the numerator? And what are we going to put in the denominator? There we go. So you know what? We're not going to use the power property. We're just going to evaluate it like this. This is probably a heck of a lot easier. We're just going to evaluate this in our calculator. Now this says rounded to the nearest thousandth. So get your calculator. I'm going to type in a 3. I'm going to multiply it. I'm going to hit alpha y equals enter. And I'm going to type in log of 1/12. And then what am I going to put in the denominator? Log of what? Was it log of 9? Like that. And we get negative 3.392. But if I round it to the nearest thousandth, That'd be negative 3.393. And that's what I'm gonna type in. Negative 3. If it'll let me. Hold on. It's not letting me. Oh, there it is. Negative 3.393. Okay. All right. Let's just do one more, and then we'll move on to the next topic. Okay. What does that say? 6 times log base 7 of 681. So let's use the change of base formula. 6 times, what's going to be my fraction that I'm allowed to use? Log of what over log of what? Log of 681 over the log of 7. And that's what I'm going to type in the calculator. I want you to practice doing it this way because while you don't necessarily need to do it this way in most calculators have the feature, all right? Most calculators have the feature of alpha window number 5, which allows you to be able just to type in whatever base that you want and whatever number that you want, okay? So you don't have to use it in this TI-84 plus CE, but the calculator that I had back in the day, you couldn't change the base. What's the only thing you could use? The common log. You couldn't do alpha window number 5. I've been kind of not telling you guys about that because that just, okay. But you understand why I wasn't going to tell you about it, because it doesn't help you in life when you have to actually solve it by hand, okay? So right now, what do I want you to practice doing? 6 times the log of 681 over the log of 7. I want you to learn how to do the change of base formula. So I'll go ahead and do that. 6 times. I'll put alpha y equals enter. And we'll say the log of 680, was it 681? Make sure it was 681. All right, good. Over the log of what? What was it? 7? Okay, log of 7. Okay. So I'm going to put 20.115. Ooh, I got to round it. 20.115. So this is where, if you're going to make a mistake, you'll probably be able to type it in the calculator correctly, but you'll forget to do what? You'll forget to round that to a 5, and that does matter. All right. Now, this next one is where you actually have to use the change of base rule in order to figure out the answer. So what I'd like you to do, we're going to do 4 of these, okay? And I'd like you to take this right here and put it in your journal, okay? And I'm just going to write it with you. This is using the change of base rule, all right? You can't just type your answers into the calculator and expect to get an answer. So here we go. So I have the log of 3 of base 3 of a times the log of 3. Now, if I use the change of base formula, I can rearrange this guy. I can rearrange it as the log of a over the log of 3 times the log of 3 over 1. So what did I change? What did I keep the same? I kept this guy the same. What did I change? I took this and did what with it? Made it log of a over the log of 3. Now what ends up canceling out? Those, right? And what are we left with? That's why the answer is A. Here's the next one. I'm going to write it slow so you have a chance to write it down with me. The log base 7 of A times the log base B of 7. So I'm going to use the change of base rule. The change of base rule says the log of a over the log of 7 times, here we have the log of 7 over the log of b. Okay? Just remember, this goes on top and this goes on bottom. This goes on top and this goes on bottom. Now when we do that, what happens canceling out? The log of 7s cancel out. Interesting. We have the what? The log of a, right, over the what? The log of b. Like, I don't see it anywhere, Mr. Demuth. It's just not there. But it is, because now we got to use the change of base formula to get it back to its original form. So if this is on the top and this is on the bottom, what's it going to change to? That's on the top, that's on the bottom. Then that's going to be what? Log b of a, because the a is on the top and the b is on the bottom. And voila, there is the answer right there, hiding in plain sight. I like that problem. That's a good problem. I might use that for the final. Just change up the numbers a bit. All right, here we go. Remember I said I was going to do 4 of these babies. So hopefully by the 4th one you'll be like, I got the pattern. I got it. All right, here we go. Ready? Log base 2 of c times log base c of 2. All right, help me out, guys. When I say help me out, I'm not asking you online that are looking at this because you can't really help me. But there are people in my classroom right now that could help me. Could you guys change what's going to be on top? So what's going to be on top? Log of c. Very good. Log of c. What's going to be on bottom? Log of 2. Perfect. Just like that. All right. What's going to be on top, everybody? Sorry, I got to make my cool little arrow. I know it's not that cool. All right, you don't have to criticize me. Don't leave me any comments. I don't need it. All right, so log of 2, or any mean tweets. I don't like them either. Don't worry, I don't have Twitter because it's ridiculous. Who cares? All right, so interesting. What cancels out? What? That guy cancels out that guy. That guy cancels out that guy. It looks like we're just left with a what? Just a 1. Because any number divided by itself is 1. I know 0 divided by 0, you can't do that. But other than 0, which is impervious to being divided, all right, it's just going to be a 1. This is fun. Let's do one more. Oh, one of my students like, please just kill me. No, no, no. Life will do that on your own. Okay, so right now, we're going to write log base a of 18 times log base 3 of a, just like that. So write it down. All right, let's check it out. What's going to go in the old numerator, everybody? That's a horrible line. Log of 18. What's going to go in the denominator? The log of a. Beautiful. Then we have the log of a over the log of 3. So what cancels out this time? The log of a's cancel out, and we're left with simply what? Log of 18 over the log of 3. But we don't remember, our answer's not that right there. So what do we have to do? We got to go back to our change of base formula. We got to go backwards, right? So how do we go backwards? We write log. What number is going to be our base? It's going to be base 3, and we're going to put in 18, and that's going to be our... So you got to know how to go from here to here, and backwards and forwards and backwards. All right? Looks like that answer is what? Hopefully you see the answer. Ba-dum-bumch. If you're wondering why my jokes are always so bad, it's because I'm a dad. And that's what we tell bad jokes. And that's it. So keep going, keep growing. Good luck. Have a wonderful day. That's it.